All right, recording is started. Good morning, everyone. Today is Friday, November the 5th. There we go. Wrong mic setting. So it looks like 158 bacteria. It's like everyone's saying 158. And you are all correct. Nicely done. There's the formula you should have derived. And then this is the formula simplified. 1 minus a quarter is 3/4. And then it looks like everyone got t over 3. Very good. And you put 10. Good, 10 over 3. Typed it all in, and all of you should have gotten that. And then rounding, because this is living organism, bacteria in this case, so we can round to the nearest whole number. If it was money, you'd round to 2 decimal places. Oh, you forgot the point? Yep, that's important. All right. All right, there is a correction on the quiz. So on the 4.04 quiz, which is for this section. Now, we have, what, is it 2 days of 4.04? Just double check. So 4.04 has 2 lessons. So today and then on Monday. So when you're doing the quiz, if you get this question, there is a typo. So they give you this problem here, and they tell you that the domain is this, but it's wrong. It should be -4 to infinity and not 4 to infinity. And that's based off of the horizontal shift being shifted to the left 4 units. So yeah, it's just a typo. I don't think it's going to change your answer if you just happen to miss over that part. But, well, actually, I think it would. But anyway, yeah, so there's the correction. You've been warned. Okay, inverse functions. This is something you probably learned about Algebra 1 at least. And we're going to kind of apply it to some harder problems. All right, focus on this lesson. We will focus on calculating the inverse function and its domain and range. Rather easy, because we've done this before, domain and range in the past, like in Unit 1. All right, this part will not be so the part that will not be discussed is whether the function has an inverse that is a function itself. I might mention it, but because we can have what's called invertible and what's called non-invertible functions, and on your test, you might make a little asterisk. It's going to ask you about invertible and non-invertible functions. So the invertible functions is when the domain and range are swapped, and it results still a function. So in other words, invertible functions need to pass the horizontal line test, which is just like the vertical line test. So we're used to using the vertical line test to determine if it's a function. Well, now we're going to use the horizontal test to identify if the inverse is a function. So to be invertible, it has to pass both vertical and horizontal line tests, meaning if you draw a vertical or horizontal line, it can only pass through 1 point at most. That means it's invertible. Non-invertible, it would fail the horizontal line test, hitting more than 1 point. All right, so calculating the inverse function. Maybe you remember, maybe you don't. So super easy. All you gotta do is switch the x's and y's of the function. That's step 1. Step 2 is resolve the equation for y. And then step 3 is just to show the answer with this notation. F of -1 of x, this means just the inverse function. So for example, everyone pay attention here. We have the function f of x equals 4 over x minus 1. Don't forget, f of x means the same thing as saying y equals. So we're just going to I'm just going to rewrite it with just y equals, just because it's easier for us to look at. And then we're going to do what step 1 says. We're going to switch all the x's and y. So wherever you see a y variable, rename it x. Wherever you see an x variable, rename it y. That's your step 1. So far, so good? We just renamed them. Next step, we want to solve. We want to solve for y. Oh my goodness. Alexa, stop. Alexa, stop. I don't even know. Randomly thinks I'm talking to her. All right, so to solve for y, what can I do? What should I do? Or what would you do? Multiply by -1, multiply both sides. So I like what Noah's saying is multiply both sides by y minus 1. So y minus 1 on this side, y minus 1 on this side. And then what do we do? Then divide by x, yes. So off to the side, I'm going to write that out because I do want to show you something. So make sure you're paying attention. I'm going to show you a little shortcut. So we can multiply both sides by y minus 1, and we're going to have x times y minus 1 on the left. And by multiplying by the denominator, it cancels out on the right. All right. Everyone really good? Everyone's good on this step? Okay. And then like one of you said, or more than one of you said, we divide both sides by x. So we get y minus 1 equals 4 over x. Good so far? And then our last step is to add 1 to both sides. And then we get the answer, y equals 4 over x plus 1. So I'm going to show you a little trick. So we showed the steps of multiplying both sides by y minus 1, and then our next step was to divide both sides by x. Hopefully I said that right. The trick that we can use, that I use, is when you have basically a fraction equals a fraction. Remember, this is x over an indivisible 1. We are allowed to swap diagonals. So I can swap this x with this y minus 1. It is a really cool math trick when dealing with a fraction equals a fraction. So we are going to swap those diagonals, which you can see why the math works, because we did show the steps over here. Is that clear? Anybody already know this little trick? No? Well, now you do. So it'll save you showing 2 steps. So you are allowed to swap diagonals when you have a fraction equals a fraction. And it benefits us here because we're trying to solve for y. And then, so we swap diagonals and then we add 1 to both sides to get the same answer that we got before to the right. So that was step number 2. We solved for y. Next, we want to rewrite this as f of -1 of x. So the answer is f of -1 of x is equal to 4 over x plus 1, just like the answer over here. So that's it. So again, we switch the x's and y's, then we solve for y, and then you rewrite it as f of -1 notation. Does this look familiar from one of your previous classes, I hope? It should. The problems that we're going to do are made a lot harder, though. Because what fun would it be if it was just as easy as it was the first time? So another perspective. One thing that we can do, if you print this out on your printer, and then if you have like a graphite pencil, or like a really, I guess, runny pen that doesn't dry very fast, what you can do is you can trace over this parabola with lots of passes with your graphite pencil or lots of passes with your felt pen, um, and make sure it's doesn't dry very fast. And then what you're going to do is you're going to fold your paper over at an angle. So that way this top left corner meets this bottom right corner. We're going to crease it along this edge. And then once you crease it, it's going to cause this to basically rotate, and it's going to be pointing to the right. And when it's folded in half, then you want to use like your hand and just kind of rub the top of the paper to try to transfer the pencil or the pen. And then when you unfold it, it's going to transfer wherever you, um, wherever this page met this page. That is the inverse function. So in other words, the inverse function on the graph is reflected over the line y equals x. And you may have learned that in the past. Yes. So Noah says, so the inverse would be a horizontal parabola. Yes. So what that looks like, let me just plot some points of what the inverse of this would look like. So it's still going to cross this point. It's going to cross this point. It's going to cross this point. Then let's see, over 2, up 1, 2, 3, maybe 4. So maybe over here and maybe over here. So your inverse graph will look something like this. Not perfect, but close enough. So you learned when you had like a table of values. So let's create this table of values for this problem here. You have your input and then you have your output. So for the original function, let's plug in -2, -1, 0, 1, 2. So -2 squared gives us +4, -1 squared is +1, 0, 0, and then back up. So we created a table of values. And you can see that over here. We have -2, 4, that's off the graph. We have -1, 1. We have 0, 0, 1, 1, and 2, 4. So that is the original function. The inverse function, when you have a table of values, what do you do? What do you do? Yeah, you just swap them. Y becomes X, X becomes Y. You swap the points. So your inverse graph with a table of values, X and Y swap. So instead of -2, 4, we now have 4, -2. And you can see that 4, -2. There's that point. Does that sound familiar with the table of values? You just swap X and Y to get the inverse. You should have learned it. I'm just going over it. We're not going to use that concept, at least in pre-calc, but I did want to remind you that if you have a table of values, you can just swap them to get the inverse coordinates, which kind of makes sense because if we're solving an equation to do that, we just swap X and Y and resolve. So it sort of kind of makes sense that if we have points, we can also just swap X and Y, and that's your inverse. Now here's another question. Looking at this original function, y equals x squared, does it pass the horizontal line test? It does not, no. So going back to the definition of invertible and non-invertible, this does not pass the horizontal line test. So y equals x squared would be considered a non-invertible function. And it's because the original function fails the horizontal line test. So y equals x squared is considered a non-invertible function. And that's really all that means. All right, we got 7 examples. The problems go from easy to, well, a little more difficult. All right, we all ready? So we're going to state, what does it say? So we're going to find the inverse of each function. We're also going to state the domain and range of each function. And this is the hard part for whatever reason. I guess all of you, or most of you, never really liked learning domain and range. All right, first one. So looking at this function right here, what is the domain of this function? Remember, domain is all your inputs. Let's see how many of you can remember how to do that. So what is the domain? So Noah says all real numbers except for -1. And I'm guessing he's saying everything besides -1, because if you look, if you put -1 in for n, it causes it to divide by 0. And that's why he's saying it's everything except -1. So remember, your domain is based off of your VA, and we have a VA at x equals, or in this case, n equals -1. So we VA at -1. So in other words, like what Noah says, everything except -1, and then there's the interval notation. So that's your input. All right, now looking at this, what is the horizontal asymptote? This one's a little harder. So think about those. Remember, like the whole like top heavy, bottom heavy, even. A little hint here. So if you notice, n to the first power. So this is going to be a bottom heavy. So what is the HA when it's bottom heavy? Remember. So if it was top heavy, there would be no HA. If it was even, you take the ratio of the coefficients. And if it's bottom heavy, what is the HA? This is from Unit 1. It's been a while. There you go, Enzo. Yeah, y equals 0. So the HA of this is y equals 0, but because we have a vertical shift, what does the HA become? Oh, you checked your notes? Well, at least you had your notes. Yeah, so y equals 3. So if you graph this, you would see that we have an HA at y equals 3. And G of n equals 3 is the correct notation. But for these, if you forget, you can just graph them, and hopefully you can kind of see them. And for this graph, you can actually see it doesn't cross when y equals 3. So remember, range is based off of the HA. Now, the reason why we want to find the domain and range for the original function is because we need the domain and range for our inverse. And I would say usually, but not always, finding domain and range of the original might be easier to figure out or easier to see from the original versus the inverse that we're actually going to find. Now, when we solve these equations, we switch x and y. If we had a table of values to get the inverse, we also switch the coordinates x and y. So what do you think is going to happen from the domain and range of the original to domain and range of our inverse? Take a wild guess. They swap. Absolutely. They swap. So once you know the domain and range of the original, oops, wrong box. We can write the answer of domain and range for our inverse. So if the domain of the original is what you see on the screen, that means the range will also be that same interval. And the range of the original problem we have on the screen already, that means the domain of our inverse will be that. And that will be true for every problem. Super easy? Super easy once you know the domain and range. And that's the hard part. This is the hard part for a lot of people. Okay, now let's actually solve for the inverse. So when you're given problems that have like g of n equals this stuff over n plus 1, whatnot, I like to rewrite it in terms of y and x. For whatever reason, it's easier for us to see a problem with the classic x and y variables. So I just rewrote the problem with y and x. I think it's psychological. Do any of you agree with that? Just easier to look at. Yeah, so I just write, and then we solve. Now, can we do the trick where we swap diagonals? Can we do that little trick? Correct. We cannot, and it's because we have that this equals a fraction plus a number, so we can't. And there's a few ways we can approach this. We could subtract 3 both sides, and then we would. Oh, actually, sorry, we have to rename it. Sorry, jumping ahead. We could subtract this both sides and then have x minus 3 and then swap y plus 1 for x plus 3. I don't know. If I was smart, that's what I would have done. Hopefully I did. Okay, I do. So we add 3 to both, sorry, we subtract 3 to both sides, and then we can swap, remember the entire, so we have this over 1 equals that fraction, so we can swap these two terms with each other. Little shortcut. It is a big time saver using that trick. And then we're just going to subtract 1 both sides. And that's it. And then rewrite in correct notation. So f of -1, or in this case, g of -1 of n equals this answer. All right, how y'all feeling about finding the inverse? Good or almost good? So let's try one on your own. All right, g of x equals the cube root of x plus 3 minus 3. All right. So let's find the domain and range of the original first. And sometimes graphing it might be a good idea. Because this is a cube root, can our x be negative? The answer is yes. Cube roots, you can have negative values. Like the cube root of -1 is equal to -1. There's no imaginary answers when you're dealing with cube root. Because -1 times -1 times -1 is still -1, so that works. So little tricky. Just want to remind you about Q, like anything that's odd. As far as I know, if it's odd power, you're going to have basically all solution or all numbers for your domain are possible. So with that said, what's our domain? Yeah, some of these concepts, we haven't dealt with them in a long time, so you're a little rusty. Yeah. So domain is everything, and then what's our range then? Yeah, range is also everything. And again, graphing this might be an easy way to see it, to see that it's everything. But yeah, we don't have any holes. Okay, everyone, go ahead and find the inverse of this function. Give me a green check when you finish it. So waiting for a few people. It's not a very long problem. You should be able to do it in one, two, looks like 3 steps, 3 or 4. Right. Anybody have the final answer in correct notation? What is the inverse? So g of -1 of x is equal to x plus 3 raised to the third power and then minus 3. Like 2 of you agree with that? Yeah, let's take a look. Yeah, very good. Perfect. Who got that one correct? All right, looks like almost everyone. There's a couple of you that didn't. We're almost got it right. All right. So for this problem, after you rename x and y, what was your first step? Add 3 both sides. Very good. All right. I'm sorry. Well, after you switch it, sorry. Add 3 both sides. Then what? Cube everything. And so we're going to cube the left. Remember, when you cube the entire side, you don't cube the x and the 3 separately. You have to cube the entire side on the left. You cube the entire side on the right. Well, cubing a cube root, those cancel out. Stuff inside carries down. And then here, if you were to actually expand this, you would have to write this 3 times, x plus 3 times x plus 3 times x plus 3, and FOIL it out, and then FOIL it out again or whatever. But you don't have to do that. You just leave it in this factored form, this binomial cubed. And then your last step was to subtract 3 both sides. So I'm guessing that if you missed this problem when you cubed both sides for whatever reason, maybe you cubed the x and the 3 separately, which is a no-no. Or you tried to actually expand this and you are doing too much work. Looks like no questions on this one. Is it standard to keep it factored form? Will there be times when it will be expanded? Nope, leave it in factored form. Leave it in factored form. Okay. Looking at this, what do you think the domain and range is? Well, lag's not good. All right, what do we think the domain and range is for the original function? And again, if you look at a function and you're not sure, just go in the Desmos and graph it. But this is an odd power, so one side goes up, one side goes down. So domain, yeah, domain is everything. We don't have any exceptions. Like any value could be for n. The domain is everything. And because this is an odd exponent, we know in behavior that one side goes up forever and one side goes down forever. So that means the range is what? Yep, range is also everything. And if you can't see that by looking at the equation, just go to Desmos and graph it. It's pretty easy to see. When in doubt, right? So that means domain and range is, well, everything. Okay, everyone find the inverse of this function. Give me a green check when you finish it. All right, what did everyone get for their end function? So we got the fifth root of x plus 1 and then plus 2 on the outside. Oh, g of negative 1. Yep, it should be g of negative 1. You're right. Because that's what the variable they used. And then don't forget we're using the n variable and not the x. But I get it. I don't think I'd mark it wrong on a TGA if you did that. I'd probably circle it, but I wouldn't go that far. All right, let's see what the answer is. Yeah, so it doesn't really matter where that 2 is. If you're talking about standard form, I'm pretty sure we want to put anything with the radical at the very end. So you're going to have like your highest powers first, down to your constant, and then the term that involves radicals at the very end. So this would be the correct order. I wouldn't mark it wrong if you had them switched. I won't be that picky on a TGA. But you should have it this way. All right, who got this question correct? It's like almost everyone. Almost everyone again. Let's take a look at our steps. So we switch x and y. And then what was the first step after this? Yeah, so we have to add 1 to both sides first. So before you get rid of this exponent, we need this term by itself. So you have to add the 1 to both sides. And then what was your next step? The fifth root both sides. Yep. And then we're going to add 2 to both sides. And that's it. That is it. And then rewrite it, of course. Hopefully everyone, if you made a mistake, hopefully you see your mistake. All right, let's try a harder one. So we got four examples left. This one and then 3 more. All right, so looking at this, what is our domain? It is all real numbers, and it's because it's a cube root. Because it's a cube root, we could have anything under the radical unless it makes it divide by 0. But luckily, there's no variable underneath here to affect that. So in this case, cube root of this, yeah, your input can be anything. And then your output can also be anything. Yeah, cube roots, fifth roots, they're kind of easy determining domain and range. All right, everyone find the inverse of this one. It looks like it's like 1, 2, 3, 4, 5, maybe 6 steps. Maybe that's what I used. I don't know. Way to go. So wait for one more of you. All right, what did everyone get? 2 times, so 2x cubed plus 1. 2x cubed plus 1. Take a look. Very good. 2x cubed plus 1. All right, who got this one correct? Almost everyone. Looks like a couple of you made a mistake somewhere. All right, let's take a look at the work. We switch x and y. All right, what was your next step after this? We want to cube both sides because we got the cube root of all that stuff, and to get that stuff out of there, you have to cube both sides. And then what did you do? Multiplied by 2, both sides, good. And then your last step. Yep, and then add 1. Yep. And then we rewrite it in the correct notation. F of -1 of x equals 2x cubed plus 1. Very good. All right, that one should have been simple for the most part. All right. So this one is a parabola. How does it open? We just had this unit. How does it open? It opened upwards. Yes. What is the vertex? Just a review question. What's the vertex? What's the vertex? 3 comma -1. Very good. 3 comma -1. Ooh, I have a typo. That should be 3 comma -1, not -3. Sorry, that should be a plus. I gotta fix that. All right, and then what is the domain of this parabola? Everything. What is the range of this parabola? Remember, it opens up. Everything greater than -1. Yes. So from another typo. So that should be parentheses. I don't know how I missed this. So I double check my, everything looks good when I click through it really fast. Yeah, that should be parentheses -1 to infinity. It doesn't actually touch -1. Oh, no, it does. I'm sorry. That's a mistake. Hold on. That is correct. Sorry. That is a parabola. I'm thinking something else. I'm thinking logs and natural logs. Yeah, because it's a parabola, the vertex is at 3 comma -1. So it does actually touch -1. So that's why it's a bracket. It's a solid point and it opens upward. So from -1 is the lowest y value we touch and it goes up forever. So that is correct. Sorry. So for the final answer for this one, what do we do with domain and range? Yeah, you flip them. So the range becomes that, everything, and domain becomes this. Right, everyone now find the actual inverse and give me a green check when you finish. So I will probably go over time today, just like most days. But I would definitely stick around for the last 2 problems. What did everyone get? No problem, Noah. Just I would recommend watching the end of this recording later. It'll be good for you, trust me. All right, so f of negative 1 equals 3 plus the square root of x plus 1. That sounds like it's correct. Oh, it is plus or minus. And what do you actually have plus or minus? Oh, they do. Okay, some of you actually have plus or minus. Some of you forgot it. So don't forget, whenever you use square root, fourth root, six, whenever you do an even root, both sides, don't forget plus or minus. God, don't forget plus or when it's an odd, when you do the index, an odd index, both sides, you don't put plus or minus, but when it's even, you do. That's a good question, Brady. All right. So other than the plus or minus, how did everyone do on this answer? Oh, yep. Brady, because of you, not everyone got it right. How dare you? You're welcome. So let's take a look. All right, we rewrite it, switch the variables, add 1 to both sides. Then, Brady, we do what to both sides? Yeah, we have to square root it. Don't forget plus or minus because it's square rooting. And then we add 3 to both sides. Good, good. All right, so second to the last problem. All right, so looking at this original problem, what does the graph look like? Well, it's a parabola opening up. Yes, you are correct. But the problem is this is in standard form. So we could probably pick out domain and range kind of easy from this. We know it opens up. We don't know the vertex. But we do know the domain is all real numbers. And the range for this one is not as clear. Not as clear. It's because it's in standard. Sorry, this is in general form. We need to put it in standard form to see what that vertical shift is. So it is 3 and greater. And you could graph it in Desmos and pick it out really easy, or we can just do the math. So we're going to have to factor that trinomial by completing the square. So I leave some space, and this is another way to do complete the square. Rather than add and subtract to both sides, we can just add subtract to the same side. So we take that -2, we divide by 2, and then we square it. So -2 divided by 2 is -1, and then -1 squared is +1. So we are going to add 1, but we're also going to subtract 1 to the same side. Again, this is another way to complete the square by only affecting one side. Because +1 -1, you're still adding 0, so it doesn't change the actual value. It just changes the way it looks. And then x squared minus 2x plus 1, that factors into the binomial x minus 1 quantity squared. And then we carry down the -1 and that 4 because we used these 3 to factor that, complete the square. And then -1 plus 4 gives us +3. And now we are in standard form. And that's why the range is from 3 to infinity, parabola opening up. And we can also pick out the vertex 1, 3. All right, anyway, everyone do the inverse of this problem. Ready, go. And here's a tip. Rather than start this problem over, I would continue off of this, because going from the original in standard form to the inverse is a lot easier than just starting over, because you're going to have to do this anyway. There's your hint. All right, what did everyone get? So f of -1 equals 1 plus or minus the square root of -3 plus x. So remember, standard form, make sure you have the x before the -3. Don't forget your parentheses when typing it like that. So let's take a look. Let's take a look. So we know to switch x or domain and range. And then the inverse is equal to 1 plus or minus the square root of x minus 3. So I see a little mixture of plus and minus in there. What you got, but typed it wrong. Okay. It looks like a lot of you got the same thing I got, whether you just had them switched. But there's actually quite a few of you that put a plus sign. So let's take a look. Now, hopefully you started off with this. So you would have subtracted 3 both sides, and that's where that -3 came from. Does everyone see that mistake? You should have subtracted 3 both sides. You got a plus instead. Okay. So the work that I have, I just started the problem over basically, and I did complete the square again. I moved the 4 over first, and then complete the square. So we add 1 to both sides in this scenario, which is how we learned it last semester, or not last semester, last unit. And we factor it, which is really, if you started here, you would have, your next step after you rewrote this as x equals y minus 1 squared plus 3, you then subtract 3 both sides, and this is where you should be after rewriting it. And that's why you probably want to use this instead of start the problem over, basically. So then all of you should have square rooted both sides, and don't forget your plus or minus because we are square rooting. And then add 1 to both sides. So nice job. All right, and the last one, the hardest problem of today is this one. Okay, it's similar. All right, start to finish. I'm not going to even show you the work of the original. All right, ready, go. All right. What did everyone get? think I'm right, but I'm going with my answer. I like it. Commit. -2 plus or minus radical x plus 4. -4 plus or minus radical x plus 4. Let's see. So the answer is, in fact, -2 plus or minus radical x plus 4. All right, who got the equation, the inverse, correct? All right, kind of, so maybe like half of you got it right. Let's take a look. All right, we switched x and y, correct? Then what? What do we do next? Well, you can't. Dividing by y is going to make a bigger mess because then you're going to have x over y equals y plus 4 over y. Yeah, we complete the square. So we need to factor this in order to factor it down. That way we only have a single y variable in our equation. So we have to complete the square. So we divide by 4. Sorry, we divide the 4 by 2 and then we square it. So 4 divided by 2 is 2, and then 2 squared is 4. So we're going to add 4 to both sides. So this was last unit. And then we have to factor the right side. What does the right side of the equation become? It becomes y plus 2 quantity squared. Good. All right, so now we got down to a single y variable. What's our next step? Yeah, we square root both sides. Don't forget plus or minus. And then what is the final step? Subtract 2. All right. Does anybody have the answer? So what's the range of our answer? It's not quite everything. Oh, I'm sorry. Take that back. It is everything. Sorry. I was thinking domain. I said range first. All right. Now for the domain. What is that? What is the domain? And you could have got this answer from doing domain and range of the original, or we could have just looked at this and done domain. And you can graph it to also help you, but this is a square root, so hopefully this helps you. Nobody's gotten it right. Oh, hold on. -4. So Enzo got it correct. From -4 to infinity. And again, I would definitely always graph these to confirm what you have as your answer. And this one, we can have x equal -4, and -4 plus 4 is 0. Square root of 0 is still 0, so that works. If we go below -4, like -5, we don't get a real solution. But -4 is the lowest x value that we can have. So it is -4 to infinity. Looking at the original problem, complete the square, +4, -4, factors to this. So we have that in standard form. And this one, you see that we have a vertical shift of down 4. It's a positive x squared, so it opens up. It opens up. We know the vertex is -2, -4. The domain is everything. And the range, we have a vertical shift of down 4. So your parabola opens up, -4 being the smallest value. That's what I'm saying, that sometimes domain and range from the original might be easier to see versus domain and range of the inverse. Right. Any questions before we stop? Yeah, it shouldn't be too bad. Some of you are a little rusty on your equation solving skills, but that's why we have class, and that's why you have plenty of examples in those modules that all of you should be doing. All right, guys. Well, thanks for coming. As I hope you learned something. I will see all of you Monday for day 2 of 4.04. All right. Everyone have a great weekend.